So today we're going to be talking about using substitution method in order to solve systems of equations. So substitution method is one of the two main methods that we are going to learn, and these are both to solve equations algebraically. Whenever you see a question that's asking you to find the solution to a systems of equations, you can use either substitution or the other method that we are going to learn later. So right now we're just going to focus on this one. So here we have example 1. It says use substitution to solve the system of equations y equals 2x plus 1 and 3x plus y equals negative 9. Anytime you see a algebraic problem where they give you two equations, you should be using either substitution or elimination. In this case, they tell us they want us to use substitution. So I'm going to write out the steps on how we solve on the side. If you need to pause and write any of it down, feel free to pause. And the step 1 is to pick your substituting equation. Once I pick an equation, I like to put a star next to it. So in order to pick the correct one out of these two right here, what you want to look for is if it has one of the variables, either x or y, isolated, meaning it's all by itself. So I want to look for, does one of these have x or y by itself? This one, the first one right here, does have y by itself. So this is the one that I want to use as my substituting equation, and I'm going to put a little star next to it to know that this is the one I'm picking. This is a very important step. Make sure that you always look very carefully and determine which equation you want to use in step 1. Okay, step 2 is to substitute your start equation into the other. We are going to replace the variable that is isolated. So what this means here is that looking at the start equation, we have a variable that's isolated, y. We need to locate where the y is in the second equation, because that's where we'll be doing the substitution. So I've located where the y is in the second equation. Now I'm going to show you how we substitute. In order to have a little more room, I'm going to rewrite the problems over here on the side so that we can see a little bit better. So I have my two equations over here. As you can see, I am going to be substituting it for my isolated variable. Whichever variable is isolated, that's where you want to substitute it in the second problem. And I am going to substitute this entire part in for y. And the reason why I can do this is because if I know that y equals 2x plus 1, then I can put 2x plus 1 anywhere that I see another y. So anytime you have a variable isolated, you can replace that whole part into the equation. So I'm going to put the whole thing, 2x plus 1. You don't include this part of the equation, just your algebraic expression. So I'm going to plug in 2x plus 1. I'm going to use parentheses anytime I am substituting anything into an equation. So I use parentheses to show that I have plugged in 2x plus 1. I've totally replaced this y. This y is now gone. And if you look at the equation, now all we have are x values, right? 3x plus 2x plus 1 equals negative 9. Once you see that you only are left with one type of variable, you know you've done the step correctly. After you've substituted your equation, our last step is to just solve for our variable. So I've written step 3 right here to solve for the variable. This is something that we've done before. If you feel comfortable pausing and solving it on your own first, go ahead and do that before I solve on the screen. So in order to solve for the variable here, first of all, I see the parentheses are, there's no numbers outside of there. So I can just go directly to just adding together everything. So I have 3x and 2x. I can combine those like terms first. Always make sure you're combining anything that's on the same side. So 3x plus 2x is, 5x. And then once we're left with this, 5x plus 1, we would just do the same operation on both sides to get x by itself. So I can subtract 1 on both sides, and this leaves me with 5x on the left, negative 10 on the right, and then I can divide by 5 on both sides. Now I have solved for x. I know that x equals negative 2, and we are almost done with solving our equation. So step 4 is our last step. Using your answer, which is over here, plug it in to find the second variable. Remember that in our original equations, we had two variables. We had x and we had y. We already just solved for x. So in order to find the other one, you can always just plug it back in. When I'm plugging it in, I suggest to always use the starred equation. This is just a lot easier to do most of the time. So I like to use the starred equation, y equals 2x, whenever I'm doing step 4. So I'm going to write down my starred equation, y equals 2x plus 1. And like I said, plug in your answer to find the unknown. So I know that x equals negative 2, so I'm going to plug negative 2 in. And then from here, I just need to do some basic math. 2 times negative 2 is negative 4. And negative 4 plus 1 is negative 3. So I know that y is equal to negative 3. After you have gotten your x value, you've gotten your y value, make sure to write your answer as a coordinate point. This is just something that you should always expect. So write your answer as a coordinate point. And that just means that we need to write it as x, comma, y inside the parentheses. So in this case, x was negative 2, y is negative 3. So my final answer here, written in the correct form, would be negative 2. Now it is your turn to solve and figure out what the solution is. Remember, if you need to go back and watch certain parts of the video to remind you how to do this, you can feel free to, but your answer needs to be reported as coordinate points. So go ahead and solve, and then I will reveal the answer. Okay, so to solve our equation, first thing we have to do, remember step 1, identify which equation you are going to use to substitute. In this case, y is isolated, so I'm going to choose the first one. Next thing that I have to do, since y is the variable that's isolated, I'm going to find out where is y in the second equation. Okay, it's right there. So that means that I need to substitute this whole thing, 4x plus 5, right here, where the y is. 4x plus 5. Use parentheses to show that you are substituting. Notice how all of these parts of the equation, the 2x, the 17, those don't change. The only thing we're doing is just plugging in a new part of the equation. Now I can just solve for x. So I'm going to add my like terms. 2x plus 4x equals 6x equals 17. And then I'm going to solve by subtracting 5 on both sides. Now I have 6x equals 12, and then I'm going to divide by 6 on both sides. So I'm part of the way there. I know what x is. Remember, in order to find the other variable, we have to plug this in to our starred equation. So I always rewrite this starred equation on the paper to make sure that I'm calculating properly. So I'm going to rewrite 4x plus 5 down, and then I want to just plug in 2. So I'm going to plug into where x is, and I can solve for y. 4 times 2 is 8. 8 plus 5. Y must be 13. When you're done, make sure that you just report your final answer or the solution as a coordinate point. So we would have 2 and 3. Okay, now it's time to try one more problem. You need to solve x equals 4y minus 6 and 3x plus 5y equals negative 1. Follow the same steps again, and then answer, and then I will reveal. Okay, so again, we want to start with choosing our first equation, the one we are going to use to substitute. I'm going to put a star next to this one because x is by itself. So I know that I want to use this one to substitute. So again, since x is by itself now, though, I need to pay special attention to my second problem. I should be plugging in my expression right here. Because remember, now we're substituting x. So we want to put it right here where I circled. So where x goes, I'm going to plug in my expression 4y minus 6, this whole thing. So 4y minus 6. This is why it's so important to use parentheses. Make sure you use parentheses here. So now we have 3 times 4y minus 6 plus 5y equals negative 1. For this equation, we need to solve a little bit differently. Because we have a 3 outside of here, we got to distribute this first. So 3 times 4 is 12y. 3 times 6 is minus 18 plus 5y. Next, all we have to do is we need to combine our like terms right here. We got positive 12, positive 5. So I'm going to add those together to get 17. And then we just solve for y. So I'm going to add 18 on both sides. Divide by 17 on both sides. And this leaves us with y equals 1. After we get that, remember, we need to plug it back in to the equation. So I'm going to look for the start equation right here. X equals 4y minus 6. I'm going to use that one. X equals 4y minus 6. Plug in what you just solved for. So we're going to plug in 1 for y. And now we just need to solve. 4 times 1 minus 6. 4 minus 6 is negative 2. So x must be negative 2. When we're giving our answer, or the solution needs to be in coordinate points. So in this case, negative 2, comma 1. If you have any questions or you're not sure how to solve anything, make sure you go back, re-watch the video, and then attempt the problems again on your own.